Hello algebra students from Pasco High. This is Mr. Montes, and if you recognize this assignment was given to you all on Monday of this week. I just wanted to give you a check for yourselves, so I was going to walk through all these problems and make sure that you guys are doing it correctly. So let's just start off with number one. We got m squared times m to the seventh. Oh, by the way, it says use the properties below to simplify each expression. We have three properties: the product of powers, the power to a power, and then the distributive property of exponents, and then the example beneath each one of those. So here for number one, we got a product of powers. I'm going to use this up here, which says I can add the exponent. So this should equal m. Let me make my pen a little bit smaller. It should be m. Ooh, no, I didn't like that. M to the power of 2 plus 7, which is going to be 9. Alright, so moving on to number 2, we got 3 to the 5th times 3. Now I know it doesn't show it, but we can think of this as a power of 1. So my base is 3, and I have a power of 5 plus 1, which is going to be 6. Alright. Number 3, have all the same base. Only difference now is that we have 3 bases here, or 3 pieces here, unlike the 2 that we had up here. So we have 3 different terms we multiply together. My base is x. I'm going to do the same procedure. I'm just going to add all of them together. 3 plus 7 is 10, plus 2 is 12. So x to the 12. Alright. Number 4, we change it up a little bit. Instead, we are looking at a power to a power. So the rule says that we multiply. So I'm going to go ahead and multiply. So a to the 4th to the power of 5 is the same thing as a to the power of 4 times 5, which is going to be 20. A to the 20. Same thing for number 5. It's a power to a power. So it's b to the power of 8 times 2, which is going to be 16. Number 6, a little bit of an interesting problem. Instead of having one term on the inside of parentheses, we have 2. So in this case, we're going to do the distributive property of exponents. We're going to use that property. Something that might be a little bit confusing is that a doesn't have a power, but I can think of this as a 1, a to the power of 1. So I have a to the power of 1 times 2, which is 2. And then I have b to the power of 3 times 2, which is 6. And moving on, number 7. Again, we have 2 bases. 4 and x are our bases. The 4 has an exponent of 1, even though it doesn't show it. And then x has a power of 3. So this is 4 to the power of 1 times 2. 2, and x to the power of 3 times 2, which would be 6. Now you can simplify this further. I can turn 4 squared into 4 times 4, which would be 16. X to the 6th. Either answer would be okay. All right. Let's see, number 8. So a little bit confusing. Toss this in there because we did have an example like that in the lesson. So if I have parentheses x plus 2 to the power of 2, I'm going to think of this thing right here as one thing. I'm going to think of that as so this whole thing right there is a term. So my term is x plus 2. And the power is 2. Now, when we have a power to a power, which is the situation we have here, power to a power, I just multiply the power times the power. So 2 times 4 would be 8. So I end up with x plus 2, quantity to the 8. Now, what some of you might want to do is turn this into x to the 8 plus 2 to the 8. But this is not true. You cannot do this. You cannot do this. If you look at the distributive property, there has to be multiplication between those. That's what that little dot means. In this case, we have addition. So this doesn't actually distribute to the x and to the 2 there. So you would just leave it as that. That's as far as we can get for now. You will be able to multiply stuff like this out when we start learning about quadratic, but for now we're just going to leave it as is. Alright, number 9. So I got a 2k to the third times k to the fifth. I have two bases that are the same and one that is not. So the 2 just stays. There's nothing I can do with that. But as for the k's, I have k to the power of, in this case, it's a product of powers. So 3 plus 5, which is 8. 2k to the 8th power. Pretty simple. Number 10, we got a bunch of stuff going on. The power of 4 is going to be 1. We got a power to a power. So I have 4 as a base, x as a base, and y as a base. 2 times 1 is going to be 2. So 4 to the power of 1, 1 times 2. X to the power of 2, so 2 times 2, which is going to be 4. And then the y has an exponent of 3. 3 times 2 is going to be 6. Now remember, power or exponent means the same thing. Number 11, x to the power of 3 y, then that's to the power of 2. Then we also have times x to the third. So we're going to do this one step at a time. We're going to kind of follow the order of operations. We're going to take care of those exponents in parentheses first, and then take care of this x to the third. So I have a power to a power here. I have the base x, the power is 3, the base y, and the power of that is 1. X to the power of 3 times 2, which is 6. Y to the power of 1 times 2, which is 2. And I still have times x to the third. So this one is actually a two-step expression as far as simplifying, because I have x to the 6th and x to the third. So what I'm going to do is I'm going to rewrite this as x to the 6th times x to the third y times y squared. And the reason I rewrote it is just to make it a little bit more obvious as to what pieces go together. So x to the 6th times x to the third, that's a product of powers. So we're going to add those exponents. So I end up with x to the 9th y squared. Done. Alright, number 12, a little bit more complicated. Just follow those rules. Again, we have a power to a power. We're going to take care of that first. I'm going to put a little 1 there on that y as far as the exponent. So I have x to the power of 3 times 4, which is 12. Y to the power of 1 times 4, which is 4. Z, I always cross my z so they don't look like 2's. Z to the power of 2 times 4, which is going to be 8. Times x squared times z cubed. Perfect. So now I'm going to rearrange this since I have multiplication between all those pieces. I'm going to go ahead and write this as x to the 12th, x to the 2nd, y to the 4th, going in alphabetical order here, z to the 8th times z cubed. So now, product of powers, x to the 14th times y to the 4th, and then times z to the 8 plus 3, which is going to be 11. And that is my answer. So although it looks a little bit more complicated, we just actually added in a few bases and an extra piece over here. But just follow those rules, those same 3 rules that we've been talking about, and you should be okay. Now, the challenge problem. Challenge problem is really just a challenge because it has multiple steps as far as simplification. We're actually going to do the power to a power rule here as well as here. Now 5 is a base and the power is 1. So this is 5 to the power of 1 times 2, which is 2. A to the power of 3 times 2, which is 6. B to the power of 4 times 2, which is 8. And c has a power of 1, so that'll be c to the power of 2. Times, powers of 1 here, a to the power of 1 times 2, which is 2. b to the power of 1 times 2, which is 2, times 5c cubed, or to the power of 3. Now I'm just going to organize myself. 5 squared, 5. I got a to the 6th, a squared. I got b to the 8th, b squared. And then I also got, and let's change this up, I'll put a little star right there so I can keep myself organized. C squared and c cubed. So I got 5 squared times 5 times a to the 6th times a squared times c squared times c cubed. I think I got everything. A to the 6th, a squared, a to the 8th. Oh, I missed my b. Well, let's go back. B to the 8th times b squared, and then times c squared times c cubed. Perfect. This turns into 5 to the power of 3. So imaginary 1 right there. A to the 6th times a squared is going to be a to the 8th times b to the 10th times c to the 6th power. So this is just really 5 cubed, a to the 8th, b to the 10th, c to the 6th. I just got rid of those little multiplication symbols in between and left them out to make it a little less messy. But that's it. What I am going to do is I'm going to go ahead and send you this exact document in an email, as well as a link to the video, which if you're watching, you probably got it. So in any case, that way you guys can all check your work. Have a good day, and later on today, I should have another lesson for you guys. Stay safe. Talk to you soon.